Our next speaker is Dora Šribar, who is a research scientist at the Department of Digital Life Sciences at the Nuvisan Innovation Campus, Berlin. Hi, Dora. Welcome.
Hi, Daria. Can you hear me and see me?
Yes, we can hear and see.
Well. Hi, Daria.
No worries. Thank you for joining. So Nuvisan Nuvisan ICB was established just like last summer. But I know that the researchers in Nuvisan, they've been working together for quite some years before, and they collected quite good experiences in the drug discovery field. So when you then moved to the Nuvisan ICB, did you have to start from scratch all the implementations?
Well, just to give you some bit of background, so basically Nuvisan Innovation Campus Berlin, so is a contract research organization specialized in early drug discovery and development. So last year, Bayer has transferred a significant part of its Berlin-based research unit for small molecule discovery to Nuvisan ICB. And basically, we got all the, let's say, experimental wet lab infrastructure from Bayer. But from the IT side, basically, we had to implement some significant part of the IT structures. And this also includes different cheminformatic workflows.
Wow. Okay. But that could actually sound like a pretty hard task. Would you like to show us how you did it and what you implemented?
Yes. So yes, I will do it in the next few slides. Welcome basically everyone who is joining us here today. So in the next few slides, I will first give you a brief overview on what kind of workflows are we building with KNIME. Then I will focus on more specific user cases in which we are using KNIME to develop different chemoinformatic workflows. Along the way, I also want to share some hopefully useful tricks and tips for the implementation. I already gave you a brief background about Nuvisan Innovation Campus Berlin. Basically, so since the transfer last year, we had to implement a part of our IT infrastructure. One of the important things we needed to consider is how we want to re-implement all the chemoinformatic workflows. We also wanted to make the workflows easily accessible across the organization and also to people without a significant IT background. And finally, we also wanted to have a flexible solution in terms that we can easily scale up the resources on demand if needed. So we searched for some time so how we want to do this. And in the end, we decided after months of planning and careful research, so we decided to go for KNIME. So basically, we obtained the license for KNIME Server Large, which we split up in 2 licenses, so one for the development server and one for the production server. Currently, we have a test phase in place. So basically, a limited number of test users have an access to development server, and they can readily access the developed workflow and test them out and give the feedback. In the near future, we plan to deploy all the workflows on the production server. Also, in some future, we also plan to integrate the workflows within the TIBCO Spotfire. This is also one of the feedback we got from the chemists that they would really like it implemented within the Spotfire. So what kind of workflows are we developing at Nuvisan ICB? So I would say that there are 3 main use cases. So first one is general everyday data wrangling and analysis. So this includes processing of different file formats, merging different files, analysis of the data points, and finally generation of some required output for the end user. The second use case is, so in-house we have a large database of live science data, and we are working on development of workflows which enable user to easily access the database and fetch the data. And finally, the large part of the workflows I'm currently working on is development of chemoinformatic specific workflows. So this includes prediction of different molecular properties. So I will come back to this in a second. And also different tools for the structural analysis, so mostly for the medicinal chemists. So in the next few slides, I will go just through, this is like a simple prototypic workflow, and I want to guide you through the steps of this workflow, and then along these steps, probably share hopefully some tips and tricks for the implementation. So I hope this would be useful for the next, like if you consider to implement something similar. So this is like just the first view, how it looks like, part of the view, how it looks like for the end user on the web portal. So basically, usually you have option to upload the SDF file and then select properties for the calculation. So from the properties, we either have like calculate some properties which are readily available via chemistry integration in KNIME, or we have like this large life science database. So we build our own machine learning models and then do the predictions based on this. So this is how it looks like, basically the overview of the several steps, just general overview how it looks like in the backend, I would say, like the workflow with all the steps depicted. So as I already said, so the calculation, so we calculate either like some standard properties, such as molecular weight or number of hydrogen bond or acceptors donors, which are readily available via chemistry integrations. For some other predictions, which are more complex, for example, different ADME endpoints, we use machine learning-based predictions. Most of these machine learning-based predictions we have in form of Python scripts. So basically, we needed to integrate this Python script into the KNIME environment. So this is the first step, let's say, of the workflow. So basically, the first step you already saw, user is required to provide the input. Then you have additional view in the web portal where user should provide ID column. This is important for the downstream processing and calculation of the properties, that you have the ID for every molecule specified. Here you can also see this row ID node. So this is just here, like just to ensure that even if in case that there is no suitable ID column in the input SDF file, that workflow can still run smoothly. So the next step is the standardization step. So we considered quite a lot how we want to implement the standardization procedure. In the end, we decided to go for the Python-based implementation. So this we have a Python node, and we use the really cool and useful Python package for the standardization, so you can check it out. I provide a link here. Additionally, so we have also added some additional, so I think that it's really cool, like the RDKit Python implementation, and then we added some additional functionalities. So this makes it quite flexible for us. What I also like is that here you can see that this is actually the shared component, and by adding different configuration nodes inside, you can easily change configuration options for the standardization and then tailor it according to the specific workflow. The next step is just like the standardization information in the web portal for the end user. So this is basically for the user to check if there are some problems with some of the input structures. So this is now the test feature still. And then a user can also download the SDF file with the error messages and then basically correct the structures if it's possible. You can also see this Uniquify ID node. So this is only to ensure that in perfect case, all the IDs should be unique for every molecule, but sometimes for some reasons that's not the case. And this node only ensures that like it's quite a smooth and easy way to ensure that there are unique IDs for the downstream calculation. Finally, so the central part is calculation of different properties. So as I already mentioned, we either use already implemented chemistry integrations in KNIME, or we have our machine learning based scripts. So some of the older models, so basically they were implemented as a Python scripts, and the problem was that they used Pandas version older than 0.20. So basically we needed to update the Pandas module for these scripts to work. And then we needed to change some of the lines of code, but in the end, everything worked smoothly. So we have also for some other models, basically we redeveloped models from scratch based on the life science database. Finally, there is like this components. So I really like that within KNIME you can use different Python nodes, and every Python node can use different Python environment, either PyEnv or Conda environment. So what I really like is that for every specific Python node, you can specify different Python environment, which gives you quite a lot of flexibility. So how I like to do this, I know that there is this Conda propagation nodes and stuff, but I really like this actually when you can specify the Python path as a flow variable, and then I usually do it in this basically component at the beginning, and then you can change the paths to the different Python environments quite easily, and this enables you quite smooth transition from one machine to another if it's needed. Finally, this is how now to the user output. So this is how simple workflow output looks like for the end user. So there is an option to download the SDF file with the calculated properties. There is also the table, usually a table with the calculated properties. And then what I really like is that you can color the cells, and chemists really like this, is that you can color the cells based on specific rules. So basically, this is not possible with JavaScript integration in KNIME nodes. Rather, you have to, I think KNIME people, they really generously provided this really cool workflow how to do this. So if you're interested, check this link I provided. I also like that you can easily add in this web portal, you can, using different JavaScript nodes, you can easily add different plots and then make interactive dashboards quite easily. And finally, we are also not limited only for this kind of output. So we also can, using BERT integration in KNIME, which is really powerful tool, we can create different template-based, for example, PowerPoint slides or PDFs. So with this, I would like to come to the end. So these are some general lessons I learned like in past few months. So I would say always check the output of the nodes, especially with the chemistry integration. Sometimes it's not completely clear how certain property is calculated. So what's the exact implementation? So when you start implementing the workflow, first check and be sure that you understand what every node does. Second, usually if you start implementing the workflow from scratch, first have a look at KNIME Hub. There you can find quite a lot of useful examples. If not, so I think the real also very strong advantage of KNIME is that you can integrate it with different programming languages. So for example, RDKit community is quite big. So even if you don't find specific solution in KNIME, you can maybe look for the some RDKit implementation for the specific chemistry functionality you need. And finally, if you encounter any problems, always go on the KNIME forum. So there is a good chance that you will find a solution there. If you don't find a solution, so I think you can always contact the KNIME support. I think they're quite helpful and ready to help you quite fast. And for me, for example, this could have in the past saved quite a lot of time and energy. So yeah, I hope this will help you, these lessons. And finally, I would like to acknowledge all the people who were directly or indirectly involved in the development of the workflows. And just to mention that we are currently expanding and we are hiring and looking for new people. So if you're interested to join us, check this on this website. And that's it. Thank you for your attention.
Thank you so much, Dora. Thank you for sharing all these tips and tricks and building the cheminformatics workflows. That's, yeah, there's a lot of time. I also find it very interesting. So you showed how easy, I can't say, but how straightforward it is to implement the infrastructure from scratch. And well, I hope it was really, it could be very, I hope that it's very helpful for the audience too. I'm going to ask and turn to Norbert if there are any new questions coming from the audience now.
Yes, thank you very much, Dora and Daria for the presentation. Yes, they are coming, and actually they align very well with these tips and tricks. So let me ask the first question, which is: did you use any chemical cartridge in your workflow, or was it only Python package that you referenced?
Only Python package.
Only Python package.
Yeah.
Okay, there is another one then. If that was so quick, you mentioned that you have developed. You have a development and a production environment. Could you talk a little bit more about how do you use these environments? What is the distinction between those ones? How do you propagate things?
Well, so let's say that development server is more like our internal playground to test the workflows and also develop the workflows, test them first. And the production server, so it's not still in place. We are currently setting this up. So this must be like this as stable as possible. So this is basically to enable other people from the company to access the workflows. So there will be, we deploy all the workflows that were checked on the deployment server first there.
Fantastic. Okay, thank you very much for that. That's a good standard, I think, what you just implemented here. There's another very straightforward question. Could you pass the link for the color table cells in the web portal, please, somehow?
So, I mean, I have it. I think the presentation will be shared. So I think you will have the access for that.
Fantastic. Okay, so look for that one, and that's also a good message to the NIME developers that there is a need for that. Another question: how long did the implementation take? Especially that you mentioned that sometimes you had to cope with 2 old Python packages, and you had to redesign some of the workflows also.
Well, I would say it depends. So minimally, like if it's really simple and straightforward workflow, then it's minimally 1 week for every step. But currently, when it's more complex workflow where you have to train the machine learning models, like it takes like maybe even months or something. So it depends on the complexity, I would say. But we are currently still also developing some other workflows. So it's a process and depends on the complexity of the workflow.
Mm-hmm. Okay. And just because we have time, I would ask you another question, which is, how did you teach people, or did you have some internal training? How did you do that?
So, well, now we have the testing phase. So I think like just small number of users from our chemistry department is having access to the workflows. So we had like a demo session, basically explain how to use it, like in the web portal. But I think it's actually quite straightforward. Like, so we had a demo session, and then we will see how it looks like when we enable the access company-wide. But we will certainly have to have a bit longer training sessions.
Okay, let us know if you can help with that. And maybe the last question for you is, hello, what is your continuous integration process for the new version release, if you have any?
You mean newer version of NIME, or like?
I suppose the question would probably, go for the NIME version.
Well, yeah, we will update it regularly, but so I think it's more question for our administrator, but we will have like certain dates, and then have a like test.
Okay, so you have a plan for that, but you didn't do it yet. It's so fresh, crispy. Okay, good. I think our time's up. So giving it back to you, Daria, and thank you very much for your answers.
Okay.
Thank you so much, Norbert, and thanks the audience for all the questions. Thank you once again, Dora, for joining and for sharing all these tips and tricks.
Okay, thanks.